Okay, so example 5 in section 5.5, a little bit more binomial distribution. An article about the college grade inflation said that only 15% of students in 1960 got an A. So if you read the article, they kind of argue more people are getting A's now. But let's pretend we're looking at a class in 1960. There's 42 students, so that's my 42 trials. And we want to find the number who had an A. So even though letter grades have lots of options, this is binomial because we're just doing an A or not. So my success would be receiving an A. So an A grade. And then not an A is my failure. So B, C, D, F are all grouped together, the way this is worded. So my N will be 42 for 42 trials. My P is the probability of an A, which was given at 15% or 0.15. And then Q is just all the other grades. So it's 1 minus 0.15 or 0.85. So as soon as we identify these two things, it helps us organize our binomial a lot. So even if these questions A and B are not asked, I think it's really important to do on your own. So we want to find the probability that 16 of these students receive an A. So we're going to do 16, and maybe you need to peek back a previous page or two to find the formula. But it's N choose X, which in this case is 42 choose 16. This tells me the number of ways, because we don't know which 16 students are getting A's. There's lots of different combinations. And then we're going to do 0.15, and then how many of them are getting A's? 16, so this will have a power of 16. So it's P to the number of successes. I, again, like it in words more than formula form. And then 0.85, the power will be the number of failures. So if 16 students get A's, we're going to do 42 minus 16, so 26 of them are not A's. Just a quick subtraction. And then we can type this on the calculator. So we'll do 42, math, NCR, 16, and then remember it's nice to type everything at once. And then I'll type it 2 ways in case your calculator looks a little different. So go ahead, type it, and then check that you also get this weird number, which I will explain in a moment. I'm going to call it 1.6, just 5/9 will round up to 6, e to the negative 4, which I'll talk about, but let me just show you. Some of your calculators look a little different, so don't do this, but let me show you what might happen. So you might do 42, math, NCR, and then it looks like this. So 16 goes in the second one, and then you have to hit the arrow to get out of that, or it's going to give you some error messages. So I hit the arrow, this arrow right here to get out of that. And then 0.15 to the 16, and then also if yours looks like this, if I keep typing, it shows up in the power, which is not what I want. So again, you have to hit the arrow to get out of the power. So if yours looks a little fancier, the arrow, the right arrow, is what gets you out of the weird things. And then you still get this weird answer. So hopefully that helps with the different ways the calculators look. Again, I have another video on just using the calculator if you need that. But so what does this 1.6 mean? So this is scientific notation, if you've learned that. If not, we'll pick it up quickly. It's like times 10 to the negative 4. A couple videos ago, we saw one where it had a positive e, so that was a really big number. This is the opposite. It's a really small number. So it's telling me to go 1, 2, 3, 4. 1, 2, 3. So I move the decimal 4 to the left. What I think of it as 1, 2, 3, 4. 1, 2, 3, 4. So it's 3 zeros, and then the 1 takes the 4th spot. So these E numbers are going to pop up more, so it's really important that you pay attention if E pops up. So hopefully that helps. So negative, we move to the left. Earlier, we did a big positive number, and we moved to the right, and we got really big numbers. So negative E's are very, very small numbers. So 0.00016. So very small chance of 16 students, exactly 16 students getting A's. So let's do a couple more. I think the worst part is, again, just how tedious the formula is. And this one's going to be pretty ugly. Be patient. So now we want at least 3 students get A's. So that means 3 students could get an A. It means 4 students could get an A. It means 5 students could get an A. And then I don't want to write them all out because it also goes all the way up to 41, 42. So that means we have to use the formula for every single one of these numbers. You can do that. I think it's like 40 times using the formula. Sounds absolutely awful. So this is one of the cases where the opposite or the complement rule would be better. So greater than or equal to 3 means it's only not 0, 1, or 2. And I'm going to subtract because we're doing the complement rule. So we add if it's easy to add. This is too many to add. So this is where the complement rule is easier. So take a moment to pause, like, is it reasonable to add these up? If not, use the complement rule. So let's go ahead and try this. So we're going to do 1 minus, and then I'll color code them all. So P of 0, it means out of the 42 students, 0 of them get A's. So I do 0.15 and then 0.85. Remember, these never change. So 0 A's means how many not A's? 42. All right, and then we'll keep going. So we'll do 1. I'm just going to write them each on their own line just to have a little more space. Only 1 A, so 0.15 and 0.85 stay the same. This never changes. 1 A, if one person gets an A, the rest don't get an A, so there's 41 left over. Oops, let's make the colors match. All right, so why don't you guys see if you can do 2 without me? So pause the video and then do 2, and then just check. So 15 and 85 are staying the same. And then hopefully you tried this without me. If not, I will explain. So we get 2 A's, so A power of 2, and then 40 students are left over without A's. All right, now we just got a tedious time of typing this all in the calculator. So it's going to be 1 minus each of these answers. So we're going to just do each of these individually, and then we'll subtract. So don't worry about the negative yet. So we're going to do 42 math NCR 0, 0.15 to the 0, and then 0.85 to the 42. And hopefully we got 0011. That'll round up to 1. And then remember, second enter is our best friend. So just change the powers and change the choose function. This will work no matter how your calculator looks. Second enter. And so I'm doing just this little piece right here. Check that you get 0080, and then do second enter one more time for the 2. Second enter makes your life so easy. Maybe not so easy, but easier. So change the 2 powers, and then make sure you change the NCR thing too. And I got 0291. So take a moment to do that. Your calculator might look a little different, and that's okay. It might look like this. Either way, we're doing the same thing. You may have noted the 0 has a similar property. If you choose 0 people, there's only one way, right? 0.15 to the 0 is 1. Anything to the 0 power is 1. So technically for that one, I could have just typed 0.85 to the 42, and we get the same answer. But you don't have to remember those shortcuts, especially with second enter. It doesn't end up being that big of a deal. So let's go ahead and find the probability. We're subtracting because we're doing the opposite case. So most of the time we add. Subtracting is the rare case when we're doing the opposite. And I got a probability of 9618. So don't subtract all the time, only when you're doing the opposite. And again, we're doing the opposite because it was too many options. Otherwise, I typically add if I can. This video is getting a little long, I'm sure, but we just have one quick last thing to talk about. And I'm using the same example, so I'm just going to keep going for it. Pause if you need a break. But the last thing for binomial is this part is more work. In 5.4 with discrete data, we just got all these numbers from a table, but the mean and standard deviation were harder. Now, these formulas are harder, but the mean and standard deviation are a little bit easier, so we get a little bit of a trade-off. So other discrete random variables, remember we got the probabilities from a table, and we would add. Now we're getting probabilities from a formula. And so the mean and standard deviation also have a formula. So these are just some nice shortcut formulas. They only work for binomial, and so I'll show you how they work in this example. If you do not have binomial, you have to do the old method on the calculator using the list. Binomial, we do not have to use the list. So that is a nice little shortcut. So let's find the mean and standard deviation. We're still looking at the A's. So the mean, the little x just says x is my variable. And we're going to do 42 times 0.15, n times p. And this tells me on average we should have 6.3 A's in a class of 42. Standard deviation, we also just plug into the formula above. So we get 42 is n, 0.15, and 0.85. So these are special shortcuts that only work for binomial. So hit the square root button and then just type everything in the square root. Make sure all the numbers are inside the square root. And you should get a standard deviation. Little x just says, hey, x is my variable. 2.314, and I'm going to go to 1 for the 8. Remember, I like 5 digits. So this is, I think, is a bit quicker than doing L1, L2 in one of our stats. So we get one part that's easier with binomial. And then we'll do some of the same stuff we've been doing. So we found all the information a little differently, but we still know how to answer if something's unusual. So let's say we have a class and 18 of those students get an A. Would that be unusual? Remember, unusual is just Z-score. So we have 18 is my data value, 6.3 is my mean, 2.31414. The Z-score formula is never going away. It's coming back in chapter 6. We use it a lot. So 18 minus 6.3, and then divide by the standard deviation. Is this unusual? Yes, very unusual. It's way past 2 standard deviations. So maybe in the article about grade inflation, they're saying, oh, now 18 students are getting A's. That's weird. This is much higher. So maybe there is grade inflation now. I don't know. But it would be unusual if 18 students got an A. And then our final thing is expected range. How many expected range of A's in a class of 42 in 1960, right? It's likely that the probability has changed, and so maybe this one's no longer true. But expected range, we've done a bunch of times too. It's just the mean plus or minus 2 standard deviations. So 6.3 plus or minus 2 times the numbers we just found. So 2 times 2.3141. We've done expected range a lot, so it's worth trying without me. See if we're picking up on this stuff. So you could pause and try. So I'm just going to double the standard deviation, and then I'm going to do 6.3 minus that number. 6.3 plus that number. So 1.67 to 10.93. We do round this number. So mean and standard deviation, we don't round because that's kind of something happening long term. It's kind of an average. It's not any individual class, but expected range is describing a class. So since A's is discrete, we have to round. And remember, we have to round within. So we're not going to use standard and rounding rules. It's tempting to go to 11, but it's slightly outside. It has to be inside the range of numbers. So I'm going to round from 2, and then it'll be all the numbers up until 10. 11 doesn't quite make the cut. So we expect 2 to 10 A's in a class of 42. So round inside, in. So the number line helps me visualize it. Even though 10.9 is really, really close to 11, 11 does not quite make the cut. And if you found the z-score for 11, it would be beyond 2 standard deviations. So I hope this is helping with binomial. I think, again, like I said in the last video, the formula is probably the worst part. But it does get easier. It's a repetitive formula if you practice.